Hi, question for Professor Tedeschi. You alluded to site-specific measures that go beyond methane reductions are going to be important in understanding the success of programs. Could you speak to what those other measures might be? Thanks.
It works when we turn it on. So what I was trying to say, there was two different ideas there. Site-specific was in the sense of exactly where you're collecting the data. So it's specific to the management, to those animals, to whatever they're consuming, blah, 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 all the things that we know, environment including. When I said we probably need to add more to it, it's for producers, for acceptability. We can try to measure and I think that was discussed in some of the previous discussions is, let's look at efficiency, some sort of a disease or some sort of other things, and then we combine the methane to that. So we provide a combo of solutions, so it becomes more enticing for producers. So coming from Texas and talking to producers about methane and all of this, it's pretty hard to try to convince them. And if there is no payment, or if the payment or some sort of remuneration is not that clear, I think we need to work on a combo, a package. That was the idea.
There's a question in the back.
Hi, my name is Musa Muntari from Texas A&M University. My question goes to Dr. Tedeschi and maybe Sara. Talking about, in terms of modeling, what is your assessment, or what do you see the position of modeling in terms of estimating methane, or using modeling to estimate methane emissions from feed additives or all the mitigation strategies? Any thoughts on that?
I'll start then, Sara, so you can help me then fix it up. So, okay, so I think modeling, the way I see is, and I was talking to Maggie Gill later about this too. I think we may have to change our approach. We need to change our paradigm, because we do have a lot of models out there, if you will, and we know that there are some deficiencies, some limitations in terms of predictability. I think there are different tools, there are different approaches that we can use, and maybe we need a different perspective on how to address this. Even in the past, we tried to include rumen microbiology in terms of rumen, but you will hear from the rumen microbiologist that there is a bunch of bugs there, and trying to model them, it's probably not going to work, and trying to group them is kind of complicated. We really need to find the groups, and for some of those, we don't even know what is out there, or in there, I should say. So I think we do need to change our paradigm a little bit in terms of that. And something that I failed to mention, whenever I talked about the first topic on the respiration chambers, I wanted to remember that the respiration chambers were designed for bioenergetics measurement. The methane came along. So we're still reusing technologies from the 40s, 50s, or something like that. And yet, is the, can I say, golden standard as well?
Sara, are you going to?
Yeah, I think to build on that, if we just think about what those models would be used for, so I'm guessing you were thinking maybe predicting impacts of, say, a feed additive, and usually that's where, say, a protocol would be for a carbon market, right, for a registry, where Oftentimes those protocols are, you can either measure the emissions or you can predict it. And of course, nobody's really measuring on farm, right? So there's often that prediction. I think there's maybe a bigger question there of saying what would that reduction be and how consistent and how robust is the data that we have to back that up. And I don't think there's a universal standard there either, which kind of to some of the earlier discussion, I think what will be expanded upon tomorrow is also an important consideration, right? If we think about the monetization of this, of just how certain are we that these reductions are repeatable across environments, across diets, across cattle types, to build into a model like that. Because usually it's just a simplistic tier 2 model using the YM factor, and we just discount that by how much we assume, right, the feed additive is. Fairly simplistic approach.
There's a question here. Great. Okay, go ahead.
Hello, everyone. Thank you. I noticed, Karen, from your slides at the beginning, there was some reference to laser-based technologies. And I'm curious, the question is to everyone on the panel, the extent to which those measurement technologies have been explored and your potential early sense on the effectiveness of them, opportunities, risks, etc.
Anybody want to take a stab on that? So I think on my slide, I had like open path lasers that are used to measure methane emissions from groups of animals. So for example, I've been working with a group of agricultural meteorologists where they used open path lasers and dispersion modeling to estimate methane emissions in a commercial feedlot, for example, or from a downwind from a barn. So essentially you use the open path laser to get a measurement of the concentration of the methane upwind and downwind, and then you combine those concentration measurements with characteristics of the plume coming from that either feedlot or group of feedlot pens or manure pile or whatever it is, wherever the point source is, to estimate the methane emission at that point source, which is a pen of animals. So it doesn't give you individual animal information, but it at least tells you kind of at the field scale whether you're seeing a reduction in methane emissions when you apply some mitigation strategies. So that would be an example.
We're currently doing a project building off of that technology of comparing that in that facility that we have with the green feed. So we'll see, that's another comparison to see how much of a correlation, if there's any, right, between those measurements for the whole facility, right? So that's another interesting thing. And of course, with those measurements, typically from, say, like an open lot pen, we don't expect to have a lot of methane, but that's another one of those considerations, right? We're always talking about enteric. Not 100% of it comes out the front end, right? There is some coming out the back end. So we would expect some of these measurements also to be different, if that makes sense, right? Because we're measuring different things when we measure it, right? So it's always important to keep that in mind as well.
There's a question here, Charles, and then there.
I'll
And then there. Oh, you have the mic. I'm sorry. Go for it.
Yeah, Juan Tricarico here. I have a question for Joe, but I would not opposed to other panel members to sharing their thoughts about it too. My question is, given the data that you showed with that apparent bias on green feed systems giving lower measurements, do you have any practical considerations or recommendations that you feel that you could give at this time to an audience like this with?
Yeah. So and also to talk about that prior comment too, I think thinking about alternatives besides green feed, I think there's been, from my perspective, this it's a tool that I have. We just put 2 in India now, and we have 3 at Cornell, and we're probably there's opportunity for more. But I think questioning, are there other tools that are as good as green feed, is a kind of a question that we should be asking, because there's probably other alternatives that have other benefits, maybe probably costs, for example, or throughput, things like that. One, I'm really surprised on some of the higher emitter cows. And I think I'm going back and we're looking at time data. I get a lot of questions because we're measuring methane every minute, right, in that chamber system, and picking out the right times. And I know these are things that Sara thinks about. But just looking at those higher emitter cows, pre-feeding data looks a lot better. So measuring data before they have a chance to go eat a meal, right? And you know, I point out my own limitations. A big limitation of mine is I'm feeding them once a day. It's very consistent, very timed, and that's not reality. But in that case, you know, most cows, that morning milking, right, then they go and have one of their biggest meals of the day. And from our perspective and the data that we have, the data between green feed and chamber looks more favorable before feeding. But we are teasing that out slowly. We are a bit distracted now with our bromoform work, but we are digging into this hourly business.
We have time for just one last question. So Charles, oh, Chris, you want to jump in there?
Yeah, sorry, on the laser thing, just
Okay,
without
sorry.
repeating what
Yeah.
other folks are saying, not all open path laser sensors are created equal, right? And so you have the dual comb spectrometers where you have very, very high precision and can do a lot with. And then on the other hand, you have like very inexpensive types of measurements that, you know, were developed for the oil and gas industry, 15, 20 years ago. And so it's, it goes back to the point about the tools and for the right thing. So in certain types of research settings, the high end is certainly very useful if you're looking at averages of big big number sets, big sets of cattle. That's it.
One last question, Charles.
So everything I've seen and heard so far looked very traditional and old school. So there has been so many advancements, specifically in emerging technologies like AI, ML, digital twin, AR, VR. So are you guys also exploring what is available out there in different industries like oil and gas, which are a lot more sophisticated, right? And trying to map some of those tools and technologies into ag and livestock sector? You can answer that.
Yeah, I'll say briefly, I've spent enough time with oil and gas folks, and like I could continue with the laser answer. And so there's very innovative things being done with lasers across drones that could get you like a much bigger map of everything. But oil and gas industry has a huge market, there's a lot of money to pay for things, and so that's part of helping to drive down the cost for some of these technologies. And so there's new stuff coming online all the time. It is definitely something we are thinking about at Global Methane Hub.
Okay, absolutely. Last question here.
Thank you, everyone. Thank you, Charles. Before lunch, there was genetics and genetic selection for methane selection, and the number of times, I lost count the number of times that phenotype was mentioned in that. So to actually leverage those potential gains and get there needs to be scalability. And there's no doubt that chambers are the most accurate and highest resolution data, but you're never going to get that to that scalability. So I guess it's how do you look at the compromises between scalability and different environments and landscapes and feed types or breeds or whatever it is, and that resolution of the data?
I'll start with that. Actually, that's a very good question. I think it goes back to the AI question or something related to AI. I'm always concerned about, keep talking about AI or ML, whatever you want to call it, to use to develop models or increase predictability and stuff like this. The problem is we don't have enough data to train all of these systems in the way that we want to train them, or the way that they should be trained. And the second problem is this: whenever these models fail, we always call for more data. Then we are out of data. If we use all the data to develop the models, if it does not work, then we are out of data. Then we have to wait for another 200 years or so. So I think the problem is this. The validation, I don't like the word, but the validation of the systems, it's kind of complicated. I think we need to develop a standardization to compare systems, or there is a system, it works for you. Then we have to develop sensors that are going to be a lot cheaper, and we can probably add on individual animals to collect data, but we still need to have calibration. Remember that even the indirect calorimetry requires calibration every other run. And if we are not recovering 98%, you have a problem. So it's the rule applies for all of the systems. It's not only the indirect calorimetry. Applies to everybody. And when I look at the variation of sensors, it's a lot of variation out there. But yes, we do need to work on that.
Okay, I think just given the time, we're going to have to cut it short. I appreciate all the questions note for next year, maybe increase the session on measurement. Anyway, please help me thank the speakers.